In this topic, we are going to study about methods of differentiation. Before we go to methods of differentiation, let us see what is meant by differentiation. Differentiation is a branch of calculus. Now, calculus studies about change, how geometry studies about shapes, or algebra studies about arithmetic operations. Calculus studies about change. Before calculus was invented, mathematics was mainly about static properties. Like it couldn't study something which was moving. And calculus was developed by Leibniz and Newton in the 17th century. There are two different branches of calculus. One is differential calculus and second is integral calculus. Differential calculus studies about a rate of change. Differential calculus studies about a rate of change. And integral calculus studies about the quantity when the rate of change is given. Now, when you say rate of change, there are many examples of rate of change. Say, for example, speed is a rate of change. It is rate of change of distance with respect to time. But in differentiation, we are not studying about this average speed. We are studying about instantaneous speed. So, differentiation studies about instantaneous rate of change. Differentiation studies about instantaneous rate of change. Instantaneous rate of change means a rate of change at a particular instant. Say, for example, suppose someone is traveling from here to Nasik. You can find the speed of the vehicle. You just have to calculate the total distance traveled by the person divided by the time taken. That will give you the average speed. But suppose the vehicle meets with an accident and they want to find the speed of the vehicle at the time of the accident. That is called instantaneous speed. So how do you calculate the speed at the time of the accident? Maybe you can calculate the speed at the last 10 minutes. The distance traveled in the last 10 minutes divided by time taken, that is 10 minutes. Maybe you can calculate the distance speed in the last 1 minute, that is distance traveled in the 1 minute divided by time taken. You want to calculate the speed at the last second or at the last fraction of a second. That is called instantaneous speed. So this instantaneous rate of change is what differentiation studies. So consider a function y is equal to f of x. Suppose x changes to the quantity x plus delta x. This is the Greek alphabet delta. Delta is used to denote very small increments in mathematics. So when x changes to x plus delta x, correspondingly y also changes. Y changes to y plus delta y. So this y plus delta y, you can write it as f of x plus delta x. So this delta y is then f of x plus delta x minus y. That is, delta y is f of x plus delta x minus f of x. So this delta y upon delta x gives you the rate of change. That is f of x plus delta x minus f of x upon delta x. But we want the instantaneous rate of change. The instantaneous rate of change is obtained by taking the limit. That is, when limit x tends to 0 or when limit delta x tends to 0, what happened to delta y upon delta x? That is equal to limit delta x tends to 0, f of x plus delta x minus f of x upon delta x. This is the instantaneous rate of change. Look at it. It is a rate of change at a particular instant. And this is denoted by dy by dx. Please remember, this is not division. So we do not say dy upon dx, it is dy by dx, because we are actually calculating the limit delta x tends to 0 of delta y upon delta x. So this is the definition of dy by dx, and this definition is known as first principle. Now, in differentiation, there are two terms that we use very often. That is, one is differentiate a function and the second is find the derivative of. What is the difference between these two? Differentiation is the process of finding the derivative of a function. Differentiation is the process of finding the derivative. So it is a process like, say, multiplication or division. You multiply 2 and 3 and the product is 6. So you multiply 2 into 3 and the product is 6. So you differentiate a function and the result you get is the derivative.